Hi everyone, it's Sorkin. Today we have a problem when we are given a graph which represents outgoing edges. So for example, for 0 node, right, there is an outgoing edge from to 1 and 2, which means that from 0 we have outgoing edge going to 1 and we have outgoing edge going to 2. The same way for the first one, we have outgoing edges going to 2 and 3, right? So it goes to 2 and it goes to 3. So we are also given a definition of terminal node. So what's a terminal node? Terminal node is a node that when there is no outgoing edges. So for example, in this case, 5 and 6 are terminal nodes because they don't have any outgoing edges. So 5 and 6, they are terminal nodes. Also, we are given a definition of the safe node. The safe node is a node if every possible path starting from that node leads to terminal node or another safe node. So for example, in this case we have 4, right, which is a safe node because we have only one outgoing edge and it goes to 5, and we have 2 which has also one outgoing edge which goes to the terminal node 5. So as a result, we are returning 4, 5. So we need to return an array containing all safe nodes of the graph. So we are returning 2, 4 because they are safe nodes, and we are returning 5, 6 because they are terminal nodes. So and also they are safe nodes. Let's take our previous example and work on it. To solve this problem, we are going to maintain a 2 Boolean array. So the first one, it's a stack, right? Why we are maintaining a stack? So the goal is here to find that if there is a cycle. If there is a cycle, it means that it cannot be a safe node. So for example, let's start with the 0, with the first example, right? 0 has from 0 we have 2 outgoing edges to 1 and 2, right? So we are adding 1 and 2 to our stack. And the next one is that what else we have? From the 1 we have the outgoing edge to 2 and 3. So we have a 2, we have 2, 3, and from 3 it goes back to 0. So which means that it goes back to 0, right? So we cannot add that because we have a circle in this case. We have a circle, so it's a cyclic, so it means that 0 is not a safe node. So we are not adding 0 to our final result. Let's take 1, right? Again, from 1 we have a 1 points to 2 and 3, points to 2 and 3, 3 points to 0, right? And the 0 again points to 1. Again, we also have here circle, and we cannot add that, so this is not a safe node. So how about 2? So from 2 we have only one outgoing edge which goes to 5, right? And the 5 doesn't have any outgoing edge, which means that it's a terminal node, and the 2 is a safe node in that case. So we are adding 2 to our result. So we are gonna create one more array of Boolean. We are gonna call it visited. Okay, let's call it visited. So first one, we are adding 2 here, right? 2 to our 2. Well, we are only marking true for the safe nodes, right? For the safe nodes. Why we are doing that? So let's say we have example here, right? Let's say that the 3 has outgoing edge only 2. In this case it has to 0, but let's say that it has to 2, right? It has to 2. If it has the outgoing edge to 2, which means that we know that the 2 is a safe node, right? We know that because we already visited that, and in that case we can return true for the 3 right away because it has only one outgoing edge and it points to the safe node, which means that the 3 also is safe node. So that's why we are maintaining one more variable. Otherwise, what we need to do, we have to, if we are not maintaining this visited, then in that case we have to go to 2 and again start this circle one more time, right? From the 2 we need to go 5 and prove that this is a safe node. If the 2 is a safe node and the 3 is also a safe node. So the same way we are doing for the others. 3 is not a safe node, right? Because 3 points to 0 and the 0 eventually points to to 3. So we have a circle here. It's a cyclic, so we are not adding 3. So we are adding 4, right? We're adding 4 because it has only one outgoing edge, and it points to 5, which is a terminal node, and we are adding 5, and we are adding 6. So this is our visited. So we are maintaining one more array of integers result where we are returning all these values. Okay, first thing that we do here, we are creating a result that we are going to return, and also we are creating two array of boolean visited and the stack. So, and they are the size of the n of our input array, input two dimensional array. So, and the next step is that we are going over our each node, right? And we are checking that whether it's a safe node or not. So, and we are calling our DFS function. If it returns us true, then in that case we are adding that to our result, and we are returning at the end of our result. So for the DFS function, we are receiving a graph. We are receiving a node, visited, and the stack. So first thing that we do here, we are checking that the if stack node, if the node that we received right now, if that is marked already true, which means that we already visited that, right? Like in our previous example, 0, right? 0 points to 3 and the 3 points to 0. So which means that it is we have a cycle, so we are returning false. If we have already visited that, node, let's say that from that we have visited that node and we mark that as a safe node. So if we are receiving that node again, so we are checking, let's say from 3 we point to 2, let's say, and 2 is we already marked as a safe node. So if we are again checking for 2, we are returning true right away because this is a safe node. So we are pointing from our node to a safe node, which means that our current node is a safe node. So the next step is that since we are if we are passing these 2, which means that the node is not in the stack and it's not visited, so we are adding that to stack and marking it as a true. And the next one, we are recursively visiting every neighbor. So for example, for 0, let's say that we have outgoing edge to 1 and the 2, right? So we are visiting 1 and we are visiting 2 recursively. If any of these cases we have a cycle, so it means that we are going to return false, and we are not adding that to our result. If not, which means that if all of the neighbors are returning true, then in that case this node is safe. So we are marking as in the stack, we are taking it out of the stack, otherwise we will not be able to perform for the next node, right? So we are marking it as a false, and we are marking that node as a safe node. So in our visited, we are marking that as a true, and we are returning true for that node. So what's the time and space complexity for this solution? The time complexity is that v plus e. V is the number of the nodes and e is the number of the edges. So about the space complexity is determined by these two array of booleans. So it's a 2 of n, and we are disregarding the constant part. It's O of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.